SOM series of missiles is a family of air-to-surface cruise missiles that provide a long-range, precision strike capability against a range of high-value targets. The Standoff Missile A, SOM-A, is an air-to-surface cruise missile that is designed to be used against heavily defended land and sea surface targets. It is equipped with a turbojet engine that provides it with a range of over 250 kilometers and a speed of Mach 0.9. One of the key advantages of the SOM-A is its ability to be launched from outside the effective range of hostile air defense systems. This allows the launching aircraft to remain at a safe distance while still being able to accurately strike designated military targets with high precision. The missile's advanced guidance and navigation systems, including GPS and INS, enable it to navigate and strike targets with great accuracy, even in adverse weather conditions. Overall, the SOM-A is a powerful weapon system that provides air forces with a long-range precision strike capability against heavily defended targets on land and at sea. Its combination of speed, range, and accuracy makes it a valuable asset for modern military operations. The SOM-B1 missile is equipped with an imaging infrared (IIR) seeker, which allows it to detect and track targets based on their heat signature. This provides the missile with a high level of accuracy, even in challenging environments or when faced with countermeasures such as electronic jamming. In addition to its IIR seeker, the SOM-B1 missile also features a range of advanced technologies, including a turbojet engine, inertial navigation, and GPS guidance, which enable it to operate at long ranges and strike targets with precision. Overall, the SOM-B1 is a versatile missile that can be used against a wide range of targets, including enemy air defenses, armored vehicles, and buildings. Its combination of advanced technologies and high accuracy makes it a valuable asset for modern air forces. The SOM-B2 missile is designed to penetrate and destroy hard, concrete targets such as command centers, bunkers, and hardened shelters. It is equipped with a dual-stage tandem penetrating warhead, which enables it to penetrate deeply into the target before detonating, thereby maximizing its destructive power. The SOM-B2 missile is also equipped with a range of advanced technologies, including a turbojet engine, GPS/INS guidance, and an imaging infrared (IIR) seeker. These systems work together to enable the missile to navigate to its target with great accuracy, even in adverse weather conditions or when faced with enemy countermeasures. Overall, the SOM-B2 missile is a powerful weapon system that provides air forces with a long-range, precision strike capability against hardened and deeply buried targets. Its advanced technologies and dual-stage tandem penetrating warhead make it a valuable asset for modern military operations. The SOM-J is an air-to-surface missile that is designed to be used against heavily defended, high-value targets such as SAM sites, exposed aircraft, strategic assets, command and control centers, and naval vessels. It is a modular missile that provides operational flexibility, allowing it to be configured for different mission requirements. The SOM-J missile is based on the existing SOM air-to-surface cruise missile technology, which is already in service with the Turkish Air Force. It features a long range of over 120 nautical miles, making it an effective weapon system for engaging targets at extended ranges. The SOM-J missile is also designed for low observability, with reduced infrared and radar signatures, which makes it more difficult for enemy air defense systems to detect and engage. Additionally, it features a Universal Armament Interface (UAI) compatibility, which allows it to be easily integrated with a range of different aircraft and weapon systems. Overall, the SOM-J missile is a highly capable weapon system that provides air forces with a versatile, long-range precision strike capability against a range of high-value targets. Its modular design, long-range, low observability, and UAI compatibility make it a valuable asset for modern military operations.